very efficient VMS. In what I like to term it's got a very small footprint, so doesn't require a lot of heavy servers to do it. And we're able, in fact, to run the DW VMS, or the Spectrum VMS on the thermal radar. So on the head unit, inside the thermal radar camera, we can be running the VMS platform, which is a really unique capability that we would have. The thermal radar just requires one license and then one license for the PTZ. So you're ostensibly getting about 8 to 16 thermal cameras with just one license in the system because of the way that we consolidate that and flow the 360 into the VMS. We're great at sending an HTTP message to DW Spectrum, and they can receive that. Patrick, you want to talk about the alarms and the way that we can trigger DW with the alarms?
Sure, yeah, we were talking yesterday, and so because of how you break it down in terms of, and I was looking specifically back at this slide with your different stops in your different areas, and you can send different messages based off of those different areas. And so in Spectrum, we can receive those messages, different messages for each area, and thus we can activate different actions through the generic event function in the standard rules engine within DW Spectrum.
Yeah.
So and that includes things like, popping up video on somebody's screen, on a particular user screen. You mentioned as far as moving PTZs to presets, but other cameras, not just the Hydra, not just the camera that is connected to the thermal radar, but other cameras in the system can pop up on the screen, or if they're PTZs, they can move to those preset locations. Yeah. Taking it out a step even further, we have our Night Watch product, which is a line of IP-enabled, PoE-powered illuminating devices. So we've got both IR and white light illuminating devices that can be used. The white light can obviously be used as a deterrent, and so you can light up different areas of the facility, just sending an HTTP from Spectrum to that illuminating device, based off of what zone that the thermal radar sends.
Correct.
So a lot of flexibility of what we can do with it.
No, there really is. The thermal radar only uses 12 watts of power. It might spike at about 15, but typically we're only using 15 watts to run a thermal radar. The PTZ will run the wattage, and the PTZ will run. It might, if it's using IR illumination, you might increase in your wattage a little bit because of that. But the thermal radar by itself is a fairly low wattage unit. We typically power it through PoE+. That's the way we power a thermal radar, and it feeds obviously right into Spectrum with a single Cat5 connector. Pretty easy. Do you want me to show the demo there, Patrick?
Yep.
Yeah, let me
switch over to
switch over to that for a minute.
Coming at you.
So Patrick's going to make me the presenter. And so you're watching a DW PTZ live tracking a target in our parking lot. We've got a truck that's starting to move and pull out there. And every time you see the PTZ make an adjustment, it just means that thermal radar's detected something and the PTZ is now tasked to go look at it. We typically choose the target by confidence level. So if I'm more confident in the hit from that truck, I'm going to go to the truck first. If I'm more confident in the person, then I'm going to go to the person first. So we'll see if it triggers. Yep, there we go. So as that person moves throughout the property or the truck or whatever, anywhere on the property, we're going to see it. So if you want to see the thermal radar feed itself, so I'm going to highlight that. So again, you see the thermal radar feed up in the top here, and you see the thermal radar feed in the bottom. So there's your 360 degrees. And as we track this target walking through the parking lot, he's going to be lit up always in this alarm zone. And we show where he's located here on the map. So all of this, everything you see, comes in as a single feed into our system, and the PTZ then just tracks it. I did want to show something real quick, Patrick. I'm just going to light up this little video here. So this is what the thermal radar is actually doing. So as it's spinning, this is what we're showing. This is what the camera is this is how we're calculating the analytics. And it might make you a little dizzy watching it, but that's how fast the unit is spinning to do that full rotation and be able to do what we do. And then we assemble it in the, we assemble it in the thermal radar and give you the RTSP stream. But the raw feed that you saw with all the flashing pictures through there, that's the raw feed that we're taking and then assembling it into an ONVIF accepted feed into Spectrum. So anyway, really neat solution. Again, anytime you're trying to cover a wide area of coverage, especially when it's in the dark and at night, we do exceptionally well with detection and what I call targeted surveillance, so 360 degrees all the time. Patrick, are there other questions or maybe questions people might have or they're sending in?
Yeah, and I'll just point out in terms of the right notification panels showing you, generic events populating into it from the thermal radar. Correct. So sending those event notifications in the Spectrum, but you have full capability in the rules engine to do other things like pop up video, move PTZs to presets, send emails, and of course through the rules engine you can also schedule that. So some of the questions that have started to come in, and by all means, anybody with any questions, feel free to type them in the GoToWebinar interface. We'll try to get to them here. So it's detecting thermal, and somebody's asking about the fire in a forest or
somebody's smart out there. So yeah, thermal radar will do excellent forest detection and like a forest fire. We cover a very expansive area because fires are so hot and something you absolutely don't find in nature by itself. So when a fire starts, we can detect that thermal emissive heat coming from the fire. We typically will see a fire about 5 kilometers in every direction. So that's a 6 mile coverage area in diameter. And like I said earlier, about 20,000 acres in that area. We can run fire detection simultaneously as we're running our thermal intrusion detection. So that's one of the exciting new features we've added, is the ability for us to run standard intrusion detection for human and vehicles. But then if you said, hey, can we monitor for a fire around our property as well, then we just add the fire analytics to the unit and away you go. One of the other innovations we're going to be making is being able to do thermography, which is, let's say you're at a substation and you're wanting to detect whether one of the transformers is overheating, then you can do that. We can put an area of interest around the transformer and detect if it's exceeding a heat that it shouldn't be. So before it catches on fire, before it explodes. So that thermography for equipment monitoring is coming as well here in a couple more months. But so a single device to do all of those things on your property.
What's the optimal height? What's that vertical field of view?
Yeah, that's a great question. So we typically tell customers to mount these units between 15 and 40 feet high, maybe 15 meters high if you want to do it in meters, but anywhere under 15 meters is going to be a good spot for us. Now, if you do want to put it high, I've got forestry services that are mounting it quite a bit higher, but they're mounting it on a pole that's very well secured, so that they don't get a lot of movement on the pole. If you've got a lot of movement from the pole, then you're going to have some issues with the analytics working properly. So it's all about keeping that pole as steady as possible so the analytics can kind of do their thing. But as a typical installation for most of our mining operations, oil and gas, crude oil transfer stations, we typically are about under 40 feet high.
So you touched on it a little bit in that video that we had in the PowerPoint, and these are kind of related, but in terms of prioritization or how it prioritizes, and I think this goes back to another question which is really, in terms of the confidence level determined. Is that confidence level information part of the metadata that can be sent over in the generic event?
It is, yeah, it is. So I always like to point out that when in thermal radar, when you create a detection zone, the detection zone that you create is very specific to the settings you give it. So every zone can be different. So I can set a zone in one parking lot and then another zone in another parking lot from the same camera, and they have different settings for the sensitivity and the confidence level. So I can say, look, in this area, I want to detect people and vehicles, and only when there's a confidence level of 65 or above. In this other area, I want people and vehicles detected, but only a confidence level of 50 and above. So, and that 50 measurement is just a numerical value we give it to say up to a 95% confidence level. I don't think we ever hit 100% because engineers never like to say 100% of anything. But typically we're going to do detection and give a confidence value. So when we see a car, when we see a person, that could come in at 65. So people ask us all the time, well, how do you differentiate between deer and dogs and critters? In our setup, and when you put the analytics in, if I have our analytics at the lowest level, which is 50, if I simply move it to about a 55 level confidence or percent confidence, then you stop seeing the dogs, stop seeing the cats and the deer and things like that. So our analytics are looking for some very specific things when they start to look at whether it's a person or vehicle or whatever it may be. So that's all configurable. And again, the PTZ is going to be driven to the highest confidence detection at the time. So
you just answered like a dozen questions all in one answer right there.
Oh.
I mean, because the next one was wildlife, so it was like it was teed up perfectly.
Yeah. So yeah, we do detect wildlife. So if there's any people that love to hunt hogs or deer hunters, man, this is your best friend in the world.
So some more questions about mounting, and in terms of you talked about in terms of mounting heights.
Yes.
But how does it deal with different elevations?
That's great. That's actually a great question, because in the calculations we make in detection, the calculations are based upon flat ground, but we have an advanced settings component to the setup of the area of interest. And you can say in this area, I'm 40 feet lower in elevation than I am from where the camera is, or I am up higher, and the detections are going to be up higher. So by doing that, we're able to put them on the map, but still do very effective detections, even if the ground is uneven or changes or whatnot. So we've put them on mountainsides. We were down in Colombia, in Bogota, doing a fire detection demo, and had a house up on the mountain that was lighting up some fires and things for us. So yeah, no, it's we can do a lot of cool stuff with that.
Very cool. So does it just detect surface heat, or does it detect let's say heat buildup behind an object, whether it's a solid or
so if it's
a hollow object?
Yeah, so we're looking for what we're actually looking for. We come at thermal from a data analysis perspective, so we're actually looking at the temperature change going on. So even if something is colder, so again, if something's colder than the environment, we'll detect on that. We're looking for pixelization change that's significant. So if let's say that guy you're watching right there in the camera, he's getting out of his car. Well, when he got out of his car, he started changing the pixels that he was walking through. The thermal pixels were changing significantly, and the heat was different in the new pixels he was populating, so we trigger on that. So we're looking for, I guess, that kind of change, and then and that's why we drive the PTZ to the target. So thermal radar does the initial detection and then slews the PTZ to say, okay, what, we're saying we detected it, what are we seeing out there? And again, there's a configuration and a tuning process with our analytics where you say, okay, I had the sensitivity of that zone or that area of interest set at this level, and my confidence level was this, and I wasn't hitting it. So I'm going to increase my sensitivity and make my changes on confidence level so I am detecting those things. So there's a little bit of a tuning process, but once you nail it in, we do incredibly well to do all the things we're trying to do.